How's it going, everybody? I have some good news, and I have a little bit of bad news for all of the people in the CCNA world. Um, the good news, this is the IPv6 video. I'm sure some of you are curious to find out more about it and get stronger in it, and what is IPv6 and what's this all about? There's also going to be the bad news. The bad news for all the CCNA folks is the Cisco just released the CCNA version 2 update. What does that mean for you? Well, today is March 31st, 2013. September 30th, 2013, the current exam numbers that have been going for the last 6 years will be retired officially. What does that mean for you? Well, that means that you have about 6 months to study, register for, take, and pass the current 640, 802, 816, and 822 exams, depending on which order you go in. Is that good or bad? Well, it depends on who you are and how far along you are. But I'm not here to discuss right now what the exams are going to entail and stuff like that. That's another video. But there's plenty of trainers out there already that have already discussed this type of stuff. So I'm going to focus on what it is that I've already set out to do in this video. I just wanted to give you guys a heads up as to what's going on. So IP version 6. For those of you that don't know what IPv6 is, this will be one of those oh crap moments. I struggled with it for a while when I first got into it because I didn't get it. And then once I watched a video a few times, read a book, read a couple chapters of a book about it, and realized what all was entailed in it. I realized it's not that bad. It's actually really easy once you get a hold of it. Now, I do have a gripe, and my gripe is this, and I'm going to get this out there so that everybody can hear it. There are, and this is my personal experience from taking classes at Gateway Tech, there are a couple of instructors, I won't mention names, but there are a few instructors in the IT department that just didn't show us how this worked. They very easily could have, but maybe they don't understand it. Maybe they don't want to deal with it. Maybe it's something new and they don't get it. I don't know. But I think, in my honest opinion, it shouldn't matter if you like to deal with it, you do like to deal with it, or you're somewhere in between. Maybe you just don't want to deal with it, period. It doesn't make a difference. The point is, this is a topic on an active certification exam. This is a topic you may be tested against. You might only see one question on the exam. We'll never know. It depends on whatever the exam decides to throw at you when you click the start button at the View Testing Center that you decide to go register at to go take your test. That's what matters. My best advice for anyone that's studying for exam certification, know what the blueprint wants you to cover and make sure you know all topics on that topic, or make sure you know all the material that topic covers, at least the CCNA level. There's for the CCNP, I've been through the material, so I'm pretty familiar with it. Cisco's kind of vague, so what I would do is, if I was you, I would find at least find someone that can give you a CCNP route switch and T-shoot exam topics, so that you can drill down what you need to study and to get really good at and to practice. But that's beyond the scope of what we're going to talk about here today. What I'm going to discuss here, and this may get kind of lengthy, so I want to cover it even though it's not something that's in the final exam. And what I mean by final exam, for those of you that aren't a Gateway student, this is going to be part of the CCNA4 WAN section. So it's not the CCNA3, but the CCNA4. IPv6 is not covered in that lab. I need to cover it because it's something that's active on the exam. It's a topic that you may or may not see. This Tuesday coming up is my third attempt at the CCNA. The first 2 times I was just plain old fashioned not ready, and it showed. My scores reflected it. And so I've spent the last 6 months or so, about the last 6 months studying for it. Did I need to study for 6 months? Probably not, but I got to a point where I felt like the CCNA was holding me back, and actually I got PO'd the last time I took it, and I was like, you know what, screw it. I don't need the CCNA, I've already got the CCENT, I'm going right for the CCIE. But because I was just mad that I had failed, and I didn't miss it by much, but it was enough for me to go, okay, I need to rethink my training strategy. So I took a little bit of a break, because I didn't know what to study, even though it told me where I was weak. So the purpose of this video is it's informational. In this video, I'm not going to get into the command line and configure anything because that goes beyond what we need to worry about. But I will shoot another video here in the near future that covers what you need to worry about. It's really easy to turn on. And I'll show you a couple different situations where you may see what you need to worry about, and you'll be able to go from there. So, without further ado, this right here, ladies and gentlemen, is an IPv6 address. Okay, an IPv6 address is 128 bits. It's 4 times as long as the IPv4 address range, scope, whatever you want to call it, scheme. The reason for that is the version 4 addressing shortage. I mean, if you go out to a telco or one of the internet name registries and you say, hey, I wanted a public IP address, they're going to hand you a version 6 address because version 4 addresses are far and few between. And quite frankly, when version 4 was deployed, they didn't expect it to blow up the way it did, and that was the reason why we're short, or that's the reason why we're short on addresses. Over the years, they've come out with a bunch of different RFCs, or requests for comments, where they've done different things to try to fix that. And the idea behind the shortage basically was brought out because numbers were allocated not appropriately. People just gave out ranges. They may have given somebody 2 or 3 Class C addresses, and they didn't need but 2 subnets, or a subnet, or just a couple IP addresses. Now, they didn't need entire range of addresses. So, allocation was kind of just first come, first serve. Universities got it, then it kind of grew and went from there. So, IPv6 was hatched, if you will, from, I don't even know, just the IANA, the Internet Addressing Names Authority, whatever it's called, came up with this. A bunch of standards bodies came up with this addressing scheme that made it a little easier for people to work their network. The best way to describe it to you is this. A version 4 address is 32 bits. Okay, and everybody knows that. This is a version 4 address. Okay, most people know version 4 addresses. Most people have the 192.168 network, and that's it. They don't need to have anything else. So, what's the point of the version 6 address? Well, one, I already just mentioned that the addressing shortage. Well, Ethernet, or was it Ethernet? Yeah, I think it's Ethernet. IP. Well, version 4 was designed for IP. It was not designed for Ethernet. So, Ethernet had to be built into version 4 in order for it to work. So, there were many revisions to the version 4 addressing scheme to allow it to do everything it can do nowadays, like NAT, RFC 1918 with the private addressing schemes, which the 10 network, the 172.16, and the 192.168. So with that being said, people they made tweaks to it just to make it work. You know, they put band-aids out there and they did what they had to do to make it work. So what do we have to worry about now? Now that's kind of a history on how v6 came to be. Is there a version 5 addressing scheme? No, there's not. Well, actually there is, but it's all experimental. You can't even find what, I don't even know what it looks like. I just know it's out there. So what I wanted to cover with you today is this. This is a version 6 address, and this is possibly what you could be assigned by the powers that be. This would be 2001 would be a valid public IP address for a version 6 address. I'm not going to drill way down on version 6 because I don't think you need to, based on what I know about version 6 at the CCNA level. At the CCNP, at the CCIE, at the CC, anything professional and above, you definitely, or telco, maybe the service provider track for the CCNA, I think you may need to drill down just a little harder on it, but for the CCNA level exam, I think what I'm going to cover here over the next 20 minutes or so is going to be more than adequate. Now, I may run a little short, a little long, but I'll try to keep it, to the point. But what you need to worry about is this. Version 6 has made assigning IP addresses to your host really, really easy. As a matter of fact, all you really have to do is go into the router and turn on IPv6 Unicast routing, and you'll get IP addresses like that. I mean, they're really, really quick. As a matter of fact, if you go to your command prompt, like if you type in cmd and you type in ipconfig, right here, this is my IP address. That right there, ladies and gentlemen, is a IP version 6 address. And an IP version 6 address will be calculated, if you will, based on all of the network cards that you have in your computer. If you only have one network card, you're only going to get one IP version 6 address. Now, I'll cover the different types of addresses here in a minute, but I just wanted you guys to see what that looked like and the different types of ways that version 6 will work in your network. So I'm going to go ahead and close that out. Basically, the way it works is this. There are link local, which is done 169. I'll go over the addresses first so you guys are at least up to speed on that. Everybody in Windows, and I believe Mac OS as well, has seen the 169 254.0.0 slash whatever it is, 16 or whatever. What this address basically means is that DHCP was not found. They didn't know how to get an IP address to the local subnet, so it gives you a per subnet IP address. What that means is, let's say this guy right here is a subnet, and you have another computer off here. We're just going to draw a computer here. This is my drawing skills are not the best, that's why I'm an IT guy. That's the computer. This guy might have, right here might have .1. This guy might have .2. What that means is only things on your local subnet will be routable. Well, I mean, this address right here is not routable, but it means that other users in the same subnet will be able to talk to you, and that is it. If you want to get from 169.254.1.0 to .2.0, it's not going to work. It's not routable. You won't be able to go from, because you need a router to get from subnet to subnet. It'll hit the router and go, denied. So you have to keep that in mind. So if you ever see this IP address, it means DHCP failed. So you see that, DHCP failed, you have to go in and figure out why. Did it not have a default gateway, or whatever the case might be. So that right there is the 169.254. The FE, this is the IP version 6 equivalent, FE80, FE80. That right there is a link local address. It means only people on the FE80 network will be able to talk to each other. Anything beyond that won't be able to talk to each other. That's simple. Now, with that being said, I'm going to bring it down here. And then we have the site local, or the unique local. And the unique local, that's kind of, well, that's going to be your, like, your router's, how can I put it to make it make sense? Best way to refer to that is like, okay, you have the Plymouth office right here. Let's say this is a Plymouth office, and you have another switch sitting over here off another Ethernet interface, and you have a switch that's got like 200 people attached to it. Oh, okay, not 200 people, but there's 200 people at this location, okay? So you'll have unique local IP addresses that will be unique to that location. This guy over here will have its own unique local. This guy will have its own unique local. So unique local means it goes specifically to that location. The unique local, which is going to be like your subnets for your private addresses, like your 10.0, your 192, your 172. These addresses are going to be the FC. So like your, okay, the 10 dot, that was a horrible 0. The 192.168. That's going to be FC 0, 0. That's what that's going to look like. And you're like, well, why do I need that? Well, you kind of do, because it's a necessary evil, and it's not that it's a bad thing, but the thing that most people forget is that there's going to be, you're not going to always be able to route which internally outside of your network. So global unicast won't be something you always want to have. I mean, that's the idea of IPv6 is so every device in the world has its own unique public IP address. So I know that's the ultimate goal of version 6. Not necessarily going to be, I don't know if it's actually going to work, but I'm just going to go over the addresses as I see them so that I can let you guys know what they are. So the FC00, I'm going to make that actually a better F. So the FC00, and that right there is going to be your unique local. Okay, so this is link local. This is site local, or unique local. Site, or unique. And then you have the global unicast. Global unicast, well, that's this. That is a global unicast address. And that 2001, I think right now currently allocated is 2001 through 3F. Oh, 3F. That's a horrible F, I tell you. Writing with a mouse is not easy. F. And then it goes, you know, ... colon, colon, and go on and on and on and on. Those are your 3 different types of addresses. Now, nothing really to freak out about. Now there is a multicast, and that is the FF02 colon slash, or colon, what is that, 2 I believe it is. Actually, let me check my documentation here. And the solicited node multicast, as it is referred to, is, one second here, I had to pull up my notes because I couldn't remember. Let's see here. Solicited node multicast, and I'll explain what that means here in a second. Unique local solicited node multicast address. Yes, FF oh, I'm sorry, FF02 colon, and like depending on what routing protocol you're running will determine what the if it's 10. Does anybody know what 10's colon is? That's EIGRP. So, but it actually, in reality, it's actually A/A, because if you go, I'll break it down and I'll show you what that looks like here in a minute, but that's basically what you're going to want to look at. This is multicast, this is global unicast, I'll put GUA, this is your GUA, I guess you could say, your global unicast address. This is what the telco is going to assign you when you go to grab an IPv6 address. Now, the nice thing about this is once you have a global unicast address from your telco, applying this stuff is so stinking easy. You're going to be like, really? That's it? And the nice thing about it is, hang on, I'm got something stuck in my wheel of my chair here. The nice thing about this is once you've got this address right here, there's this really cool thing that IPv6 has that IPv4 doesn't, and it's this. Yeah, let me clear a little bit of room here. We're gonna do this. We're gonna go take care, knock all this stuff out because you guys get that. So what we're gonna see is this. You're gonna have this thing called automatic addressing. What do I mean by automatic addressing? Well, nobody in their right mind, well, even in your left mind or any other mind you may have, or your multiple personalities, however you want to work at it, is going to want to remember all of this. That is just way too much. My brain hurts just trying to remember an IPv4 address sometimes. So why mess with yourself when you don't have to? All you have to do, whoopsie. Yes, I have Roadrunner. I kind of like it. It's reliable, to say the least. So, you have this IP address from your neighbor, or from your telco, and you don't want to sit there and come up with 500 IP addresses. So, you don't have to. All you have to do as the administrator is go to the router, turn on IPv6 on your router, go underneath the interfaces that you will want IPv6 to run on, because it's got to be applied on the interface level, and you're going to type in IPv6, what is it, IPv6, I forget the command. You are going to, I'm actually looking at my notes because it's something really, really simple. I don't need routing yet. I just want to put the address on the interface. And that command is, nope, that's security. That's ICMP, which I will go over here in a second. That is still scrolling. And no, that's show IP. There we go. Oh, duh. Really simple. IPv6 address. Oh, that's horrible. 6 ADD, and then the IP address that your telco gave you. Maybe this one. And then all you got to do at the end of that is this. You type in this section right here. That is it. The first half, the first 64 bits. And then all you have to do at that point is, once you have that typed in, is type in, well, actually you just do this if you really wanted to. You just type in IPv6 address, and then, or type in the first half, so to this point right here, and type in /64, and then type in EUI-64. Well, what does that do? EUI, is, to my understanding, doesn't stand for anything. It is just a standard that they put into an RFC that takes the MAC address of the computers that are plugged into the network, whether it's wireless, wired, or anything in between, which currently it's only wired and wireless, takes the MAC address, the 48-bit MAC address, and assigns that to the second half, so this section of the version 6 address. So what that does is it gets rid of this address for it. Well, actually it still keeps it because that's unique to the, in case this address fails, it can always revert to this one. What this does is it allows the IPv6 address to use the MAC address as the uniqueness to the computer that you're trying to configure for. So you don't have to go to each computer and configure that or configure DHCP for it. It does it for you. So with that being said, all you have to do is type in IPv6 address, this address, and then type in this. That is it. And you're like, wow, that's pretty easy. Yes, it is. So you type in the first half right here. Actually, let me clear this stuff off real quick. You type in the first half. Goodbye. And then you, once this has been put in, you do the /64, and then you type this in. That is it. You hit enter, and anything that's connected on that LAN interface will be assigned an IPv6 address. Now you can run IP version 6 and IP version 4 on the same interface. They will both have version 4 and version 6 addresses assigned to them. Not only that, the beautiful thing about IP version 6 is anytime you assign something to it to run, so like let's say you're experimenting, you want to see what's going to happen. Let me clear this off right here. You want to see what's going to happen if you, let's clear that off too. I hope I'm not losing anybody here. If I am, you can easily hit me up on email. So anytime you're running version 4 is your core IP addressing scheme, and then you want to start throwing version 6 in there to see if it's going to work, there's this thing that version 6 came out with. Well, actually the router, the iOS itself does this. It's called dual stack. So let's say you have this address right here configured on your interfaces, or on one of your interfaces. You want to do it on one LAN interface, maybe just for a few users, just to see what it's going to look like. Then you also have the 10.1.1.0/28. Okay, that's running. So you have that running, and then you have version 6 running at the same time. It dual stacks. So what it does is it takes version 4 traffic, and then it takes version 6 traffic. Oh, that's horrible. And it takes version 6 traffic. Now, it might be the other way around. It might be 4 on top, 6 on the bottom, whatever. And it stacks them so that it goes, no matter what traffic is coming and going, it's doing both. So what you could end up doing is get version 6 running completely in your network. No downtime, no issues, no IP addressing conflicts, nothing. So what ends up happening at that point is your computer goes, oh, okay, I have 2 IP addresses, so I can get off the internet 2 ways? Cool. And that's it. I mean, it's really straightforward. It's really simple to implement. Nothing major to think about or try to, figure out what to do or anything like that. So at the same point in time, not only do you have that, you also have this thing that allows, that's what I was looking for, solicited node multicast. What it does is, by dual stacking, it lets both addressing schemes work in unison, which gives you the ability to scale your network. So you could be running version 6 and version 4. Now, there's a couple of different things that you'll have to worry about when it comes to it. And these things are making sure that you can get your internal routes, your internal users out to the internet. So as soon as version 6 is applied, things change on your network, on the version 6 half. What ends up happening is, in version 6, there's no ARP. You know ARP? Can anybody tell me what ARP does? ARP? ARP? Hello? Can you tell me what the MAC address is to 10.1.1.0.10.1.1.22? I would like to send him something. ARP! The switch finds the MAC address, says, okay, well, this is the MAC address to that. Away you go. That is gone in version 6. So, what do you got to do? What happens? Well, there's this new thing called ICMP v6. ICMP v6 does what ARP did in version 4. That does 4 things. You have RA, RS, NA, NA, and NS. What does that mean? This is the router advertisement. This router advertisement says, hey, I'm a router, I'm running version 6, you can use me to get off the internet, or get off the network. This is how routers figure out who's on the network. This is the ARP process in motion. NA and NS is node advertisement and node solicitation. What does that mean? Well, if this guy needs to find out where to go or where his friend is, he sends a solicited node multicast. And it says, hey, I'm out here, I need to find out who else is out there and how to get there. The MAC address is still used. So what it ends up doing is it says, okay, I need to find out who's who and who's where. So this guy says a solicitation out. This guy responds back. So this is this way. This is this way. Okay? And he says, okay, well, I am here. This is what you got to do. And router advertisement to router solicitation, and router solicitation to router advertisement. They work the same way. So if you don't want a router to tell the network it's got a way to get off the network, you can tell it that. I'm not going to get into all that, but I wanted you guys to be aware of what's going on. Now, you're thinking to yourself, well, what happens if something screws up and 2 nodes get the same IP address? I'm glad you asked. There's this thing called DAD. No, not the guy that, you grew up with and, was married to your mom and all that other stuff. No, not your dad. Duplicate address detection. DAD. What DAD does is it sends an ICMP call out and says, hey, I have this address and I want to know if anybody else does. So it sends out a solicited node multicast to the tentative address and says, this is what I'm using. Is anybody else using it? If nobody else is using it, it comes back with its own. If it comes back with somebody else's, it knows it can't use that. Does that make sense? So, DAD sends out an ARP, an ICMP node solicitation, and says, hey, I want to use the dot, or, well, in this case, I want to use this IP address. And on PC2 is got this guy. Okay? PC1, put a 1 above this, says, I need to know what IP address I can use. So it sends out a DAD. It says, I need to find out this before I can assign. Now this is happening faster than I can snap my fingers. As soon as V6 is running, this is happening. So PC2 sends an advertisement back and says, nope, I have that address, you can't have it. So he goes, okay, well, anybody else have an address I can use? So he sends out another one, and he gets back nothing. So that tells him, hey, I can use my address. So he uses, let's say D switches to E. Okay. Okay, we'll make that an E. Okay, E goes to PC1. Alright, so ABCE goes to PC1. So now these two addresses have globally unique IP addresses because, one, the MAC address. Well, actually, I skipped that little step in the process of going through there. But actually, this is where it comes into play. So the MAC address is given out during the where was I just at? I forgot. Oh, the EUI. When the EUI is put out there for the IPv6 address, and you put the EUI statement at the end of it, the MAC address is used. Well, the MAC address is 48 bits. Can anybody tell me how many bytes that is? I'll give you a clue. 48 divided by 8, 6. 6-byte address. Well, you need 64 bits in order for EUI to work. Okay, so you end up taking that MAC address. So you take your, I don't want to write out a MAC address, but you take your 12-digit MAC address. It's 12 digits? Yeah, 12-digit MAC address, and you smack, or you split that in half. So you go your first half and your back half, and right here, down the middle, you stick this. F, 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 E, as in echo. Frank, 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 echo. You stick that in between. That puts 2 bytes of padding in between that are it just modifies it. Now, there is a catch, and this is the part that throws people off. There is a catch when it comes to this. Now I'm gonna clear all this stuff off so you guys can see what's going on here. And this catch is going to blow your mind. So, in order for there's 2 different ways of assigning EUI. You can do it yourself, which you have the UL, universal and local. Universal meant that the router took the MAC address of one of the stations on its network and just threw this in there. That means it's turned on, I believe. I have to think. Hold on one second. Okay. The way that it works with the UL and EUI, and this is probably going to be the end of the video here as soon as I get done doing this, because you guys really don't need to know anything more about version 6. Well, actually you do. There's one more thing after this. If you're using 000011112222 as your MAC address, the 7th most consecutive bit. So, well, the 7th, yeah, most consecutive, or the 7th most significant bit. I'm sorry. This is how it's changed. If it's a 1, then it is unique. It is universal. If it is turned off, then it is local. If it is not changed by you, it's universal. If it is changed by you, it is local. Hi, Jack. So basically the way it works is this. So if this guy right here is your MAC address, and just remember that this guy right here is 4 bytes or 4 bits, and this guy is 4 bits. You need to go in, and this guy right here is 0000, and this guy right here is 0000. Currently, this is universal because it hasn't been changed. So if this guy right here is flipped over to a 1, it turns to the local right here. So basically what ends up happening is this. This turns to 00000010. Well, what does that mean? Well, this is 8, this is 4, this is 2, this is 1. So if it's 0, it means it's turned off, so it's 0. If this bit is turned on, this bit is turned to a 2 because it's turned on. So it's actually 0, 0, 0, 0, or it's 0, 2, and then it keeps right on going. 0, 0, 1, 1, 1, 1, 2, 2, 2, 2. Does that make sense? I don't want to throw anybody off, but it's how it's subnetted. Now there's one last thing that everybody needs to know about this before I cut you loose for the night, is this. When you have local IPv6 running, and it's going to be running on most places, and you're running and you see the FE80, you're going to see the ISOTAP. Okay. ISOTAP is a local, I forget exactly what ISOTAP stands for, but ISOTAP means that it's going to tunnel version 6 on a local subnet. Okay, that's what that means. There's also Teredo. Teredo does the same thing. Now, is there a difference? I don't know. I'm not aware of one. You don't really need to worry about it. But ISOTAP is how it's tunneled across the local network. Now, there is one other one besides that, and I will explain that right now. It's actually really simple. You have version 4 internet for the most part. You are running version 6 across your network. So what ends up happening is you need to configure either auto 6-to-4 tunnels to get across the internet to your local sites, to your branch locations in order for it to go across. Or you need to configure a static tunnel. You can do a GRE and configure it to tunnel across. So there's GRE as well. GRE stands for Generic Routing Encapsulation. It's how you're able to tunnel, make it a point-to-point connection at that point, even though it might be going across 150 routers. GRE and automatic 6-to-4, they allow you to tunnel IPv6. So I'll draw it out like this. This is the cloud. Okay, and then you have branch office here and branch office here. Okay, this is 1 and this is 2. What ends up happening with automatic 6-to-4 and GRE is this is version 4 internet. Okay, you have a that's a horrible tunnel, but that'll work. V6. You're running V6 on your branch offices. You know, your HQ, and then you have your branch. So you're running version 6 here and here, but version 4 here. Okay, so you need to configure a tunnel to get across. So it's going to tunnel version 6 packets through version 4 internet. So that way you'll be able to still get across. That is the only thing I can think of else that you guys need to worry about when it comes to version 6. I won't get into subnetting it or anything like that. But actually, what I'll do is I'll take a minute here and I'll draw out what it'll look like when. Control Z. Let's just. Actually, I'll need a bigger section than that because I'm going to pause the video real quick and I'm going to type something out and I'll be right back. Okay, the last bit that I have here for you, copy this diagram, I guess you could say, this key. And for each one of these sections right here, I'm actually going to, where'd it go? Home. If you take one of these sections right here and go right down the middle, this half right here is 4 bits. This half right here is boy, I can't get this right. This is 1 byte, so it's 8 bits. This guy is 8 bits because each one is 16 bits. So what ends up happening here is you got to take these 4 and break it down. So remember how I showed you the Unique, universal, and local bit. Well, the same concept kind of applies here. You're going to want to take this guy right here is a byte. This guy right here is a byte. But they're broken down into two 4-bit sections called nibbles. This is how a nibble is subnetted right here. So you have 8421, and then you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then once you hit 10, you get into hexadecimal. So A, B, C, D, oh, actually E and F. So put in E right there. So E and F. So as you can see, it's pretty straightforward, and then that's how you get the bit placement down. So it's kind of similar to IP version 4, but different in the same way. So that's pretty much what I wanted to cover with you, IPv6. I know it's kind of a long video, but there's a lot to cover. So, and I'm not in here configuring or showing how it's working or anything like that, or the video would have been even longer. But version 6 is kind of a sizey topic, so I just want you guys to be aware of what's out there. So, if you have any questions, give me a shout, and we can talk about it, and I can clarify. So, I hope this has been informative for you, and I would like to thank you for viewing.